All right, everyone, it is 3:15, so I think we could get started. Before I introduce our next speaker, I just want to go through a couple quick announcements. The first is that our annual Worlds Conference is coming up on June 14th to the 17th. Second, we are organizing a career fair that is also happening on June 1st to June 3rd. Lastly, the videos for today's talk will be available and sent out sometime later. Now that that's done, I'd like to introduce our next speaker, Rahul Raina, who will be talking about AI and advanced analytics in retail. Rahul is a senior data scientist at Microsoft Canada, where he specializes in AI, computer vision, and blockchain for power and utilities, retail, and financial services verticals. Previously, Rahul has implemented AI, blockchain, big data, and analytics technology solutions for firms such as Bank of America, Bell Canada, Deloitte, and EY. Rahul holds a MSc and BSc in computer science from the University of Oxford and the University of Toronto, respectively, and he also holds a MBA from York University Schulich School of Business. Unfortunately, Rahul's camera is not working today, so he will be sharing his wealth of knowledge through his slides today. Please give a warm welcome and chat to Rahul.
So thanks again, everyone. I'm going to be talking about AI and advanced analytics in retail. You've already heard my intro, so I'm going to get started. One of the interesting things that has happened in the last few years is that even though as COVID-19 hit and we are well past over a year mark in that, the fact is that the store still remains the place of most transactions. And you can see that when you go to Walmart or Sobeys or whatever store you have. However, there have been changes in purchasing patterns, right? And what we find is that users are looking for more personalization. Users or customers, the shoppers in general, they have become more knowledgeable about different products. They compare products more often than before, and they also pay more attention to customer reviews. And then there's a whole new breed of digital shoppers who are, doing everything from ordering on, picking up on the curb or ordering online. All these things, although all these patterns were already there, they have been accelerated by the pandemic. But having said that, the store still remains, the place where most transactions occur. So the question becomes, how do we apply AI in such a setting to derive value in retail industry? And as before, most of the use cases or categories of use cases remain the same. What we find is that you can still use the know your customers types of scenarios in order to deliver superior customer experience, use it for more marketing and online shopping. You can focus more on the delivery of intelligent supply chain products, or as you think about retailers who, for example, have pharmacies associated with them. So think about how they're procuring different vaccines and other products that they need, at this time of high demand. And so a lot of those processes can be automated and be made more intelligent by using AI. Then there's obviously the fundamental question of reimagining retail. So how do we reinvent the whole business model associated with retail to unlock net new opportunities for business? And this is where Azure AI comes in, because we allow you to develop AI solutions on your terms. And what that means is that our AI services can be used by beginners, intermediates, or even advanced data scientists, developers, and business users. We also allow you to build mission critical applications by relying on the security and trust provided by Azure. And I'll expand on that in a bit. And of course, when it comes to AI, we have a whole responsible AI framework, so that as you're applying AI to these use cases, you consider the data privacy and security standards applicable to those depending on your jurisdiction. As you may already know, Microsoft AI is fueled by Microsoft Research, and when it comes to several categories, whether it's computer vision, speech, and language. When you look at the peer-reviewed benchmarks comparing the performance of different models and papers, you will see that on many of those categories we rate as number one. And we have published thousands of patents, thousands of papers, and we employ more than 1,000 researchers worldwide and globally. So by using this, our resources, especially focused on research, as well as customer-facing data scientists and data scientists in our engineering team, we are able to serve global brands. In fact, 85% of the Fortune 100 companies, they use Azure AI. We have tens of thousands of Azure AI customers, and this is based on security, trust, and compliance standards that we have proven with more than 90 plus certifications that are used across different industries and across different jurisdictions. So how do we enable that? So in order to provide value to business users as well as developers and data scientists, there is a horizontal way and a vertical way to look at it. So horizontally speaking, what I mean is that at the business user level, you've got different applications. These applications could be powered by Microsoft 365 or Dynamics. It could be built by our partner ecosystem or our own Power Platform, whether it's Power BI using visualizations or Power Apps, which allows you to build mobile applications for web, mobiles, tablets, as well as automate a lot of your business processes and connect with virtual agents while integrating with Azure AI services. And then when you get into Azure AI services, then you have to choose whether it's build or buy, really, right? So we have services that are available out of the box, which are more scenario based, such as bot services, cognitive search, content moderator, form recognizer, and so on. But then we also have services that you can take out of the box and customize it based on your data, specifically for vision, speech, language. When I say language, natural language processing and text analytics, decision making, which can be used for personalization. And then finally, there is our ML platform, which is Azure Machine Learning Service. This allows you to build your own algorithms using the compute on the cloud, and this is where you can build custom solutions. So, in terms of retail industry, we have seen a variety of use cases over the years. One of the key focus areas is obviously, as I mentioned, is know your customers, and that really boils down to personalization and real-time recommendations, intelligent conversational agents or chatbots, and customer loyalty use cases. You'll see some of the more popular brand names in this slide. And then there are other categories, which is delivering, in our supply chain. So like that boils down to demand forecasting, and then reimagining retail that can be associated whether it's increasing store efficiency, automation, or safety standards. So one of the demos, if we have time today, I'll show you is about pick up at the curb. So how can we use graph analytics, for example, to solve that problem? So just to elaborate more on know your customers, I'll just highlight the fact that among these use cases that I mentioned for personalized real-time recommendations and intelligent agents and customer loyalty, if you look at this one, like just the sheer numbers that we see in terms of AI personalization and growth, like it points to the fact that if you personalize your offers to your customers, in general, all the numbers or KPIs associated with outselling to counterparts or consumers, they just go up in terms of purchasing. So the whole purpose of using AI for personalized marketing and real-time recommendations is essentially to enable AI transformation and make relevant customer offers, as well as make just-in-time deliveries and increase the offer uptake as well as fuel their spending, or essentially to maximize revenue, right? If any of you has PC Optimum cards, you might already be familiar with it. So one of the case studies that we have released, and we worked with Loblaw on this one, it was about how we use more than 1 billion loyalty program customers data to build predictive AI based solutions to offer personalized offers. So this information is available publicly, and you can see. And when I say that, I mean, of course, the data of the customers was secure, and the experiment was conducted in a secure Loblaws environment. What I'm saying is the case study is public. So if you have interest, you can look that up. You can see some of the comments that were made regarding that. That Loblaws and Microsoft together, we were able to bring the power of AI to the market. And how we did that was, as you can see, they had certain sources of raw data, product inventory, industry data, customer data, and then we were able to, once we transfer the data to Azure, we were able to create customer spending preferences, which was then used to build our recommendation engine to develop personalized offers and suggest promotions. Those promotions were offered to customers, and then, of course, that their response, was taken into account, and this was used to offer through a chatbot service, which was to gauge the customer response in the first place. And then if you look at the technical side of the implementation, sorry, this diagram shows the different Lego pieces that we have, and I'll get to these Lego pieces in a bit. But basically, as you can see, in the same solution, we use Azure Data Factory, which allows data ingestion and transformation from on-prem or on-cloud or multi-cloud environments to Azure. Once the data is there, then it would go to Cosmos DB, which is our NoSQL database. And then that was used to store customer preferences. Azure Synapse Analytics, that is more regarding our relational SQL data warehousing type workloads. And this was used with our Azure Machine Learning platform and our Azure Personalizer service. So Azure Personalizer is one of the out-of-the-box cognitive services that uses reinforcement learning to build this recommendation engine, but it was also used in conjunction with our our custom algorithms, in order to provide an intelligent solution to the customer. Now, in terms of other services that were involved, we were using a chatbot interface. So, of course, we were using text analytics or NLP capabilities to inform the customer sentiment as a reward signal for the reinforcement learning algorithm in order to build the recommendation engine. So now I'll talk about these pieces, these Lego pieces, in a little bit more detail. So the key question now becomes, how do you get started, or how do you build these solutions? And broadly speaking, they fall into three different categories. There's AI apps and agents. These are the out-of-the-box services that are available to you. And then how do you use those services to build a solution? So for example, knowledge mining solution builds on top of those services to derive intelligence from latent unstructured data. And then the next capability is, how do you use custom algorithms in order to develop your own solutions? So if you look at AI apps and agents, we have Azure Cognitive Services and Azure Bot Service. This is what you saw in the Loblaws example, for example. And when you look at Azure Cognitive Services, there are several categories of, computer vision, speech, language, decision-making, web search, and among those categories, Personalizer is one of them that I had mentioned. There are many more. In fact, there are 50 plus services which you can use out of the box and get started. So once you take all these services, you can fine tune it to your data and then use accordingly. One of the other places you may have seen personalizer in action is Xbox. And of course, depending on some of the services, you can choose where to deploy them. So you can containerize these services and you can deploy the Docker containers wherever your data resides. Some of the examples are like anomaly detection, speech to text, text to speech, depending on how you're communicating with your customers. And then for bot development, we have our own SDK and our Azure Bot service that allows you to easily integrate these services with Azure. Moving on to knowledge mining. So if you have a lot of unstructured data, whether it's images, Word documents, PDFs, PowerPoints, whatever, and you want to search using natural language, then you can create intelligent solutions by using the cognitive services I just mentioned and enabling that on top of your search process on Azure. So let's say if, for example, you had resumes, as you know, employment is also one of the key factors in retail. So as more people are applying for retail jobs, you can use these cognitive services to scan through a bunch of resumes, apply these intelligence services, and extract semi-structured data from the resume to then essentially rank the employees. And from an HR perspective, you can type with candidates with 5 years experience, and that will allow you to easily find candidates that would be hard to find normally or manually in your typical database systems. Then you can easily visualize that with Power BI, predict with Azure Machine Learning, which is use your own custom algorithms if you want, or you can build applications on top of that. So mobile and web applications can then call these algorithms directly or through REST API and integrate with those solutions. So I already mentioned about our platform that we had out-of-the-box services or pre-trained services where the model is already built by Microsoft, but we get to fine-tune it and expose that as a REST API. So these were the computer vision, speech, language, web search, and so on. And of course, we support all the open source tools and frameworks from Visual Studio Code and Azure Notebooks or Jupyter to PyTorch, TensorFlow, Scikit-learn, and so on. In terms of productive services, really our main platform is Azure Machine Learning. And today, depending on time, I'll show you a quick demo of that as well. Azure Machine Learning Service provides end-to-end service for data preparation, experimentation management, and model deployment. And that can also work in conjunction with Azure Databricks, which is powered by Spark. And that allows you to do in-memory big data analytics and data engineering and data science workloads in one place. Both of these services can talk to our machine learning VMs, or you can use those VMs as isolated environments depending on your needs in order to spin up compute, which is powered by CPUs, GPUs, or FPGAs. And you can use them on premises, on cloud, or on on devices or intelligent edge. So drilling deeper into Azure Machine Learning Service. So for example, the data that I had previously alluded to can be used for preparation by using the SDK and the services that Azure Machine Learning provides. And once that data is prepared, you create a variety of experiments, which can then be used to register and manage a model. And that can be containerized into a Docker container, built into an image, and then deployed. As I mentioned, this can be also integrated with Azure Databricks so that as a data engineer is working on building data pipelines with various services on the cloud or on premises, the data scientists can work in parallel in conjunction with Azure Machine Learning using their favorite language and whether it's Python, Scala, R, Java, SQL, whatever. And they can work in parallel to build intelligent solutions. So this is what a typical data and AI reference architecture looks like. You may have streaming data or bash data. If you have bash data, really you can ingest the signals and then derive intelligence, which basically means um, you can do Spark or SQL workloads as well as serve them all through Synapse, which is our data warehousing solution. But if you want, you can also use in conjunction with Azure Machine Learning Service and Azure Databricks to build your own custom algorithms and build really comprehensive solutions, all the way from ingesting IoT or social media events or any type of streaming events, and then deploying those models on Azure Kubernetes Service, which allows you to expose those models as REST APIs and scale accordingly. And of course, the storage layer is backed by Azure Data Lake, and there is obviously integration with GitHub and the standard security and governance processes that are already there. When it comes to Azure Machine Learning, it's a service really for all skill levels. It also has automated machine learning capability, drag and drop capability, and code first capability. There is also a support for MLOps, extensive support really for Python-based MLOps, and I'll show you that in a second. And it's an open framework, so you can use any framework that you like, whether it's TensorFlow, scikit-learn, or so on, in order to build those solutions. So if you look at Azure Machine Learning in terms of the UI, for example, if you had to run automated machine learning, you specify your data set, you specify what columns you want to make predictions on, or what are your features, and select your compute, and that's it. And that will show the results that you can use directly by downloading or by deploying it to the REST API. Then there is the visual interface. So if you look at drag and drop capability, you can use that too. This is helpful when you're especially trying to create pipelines of different experiments, and you can link them together. And then there is machine learning notebooks. So you can use the notebooks capability so that you can essentially start writing code in Python, like on Jupyter or anything, and use the SDK for Azure Machine Learning to integrate with not only your experiments, but also add capabilities for MLOps. So model reproducibility, model validation, model deployment, and model retraining. This allows a data scientist and a developer to work in parallel. So as a data scientist is going through a typical train, validate, deploy, monitor, retrain process, the front-end developers can work in parallel to build, test, release, and monitor the apps. And of course, we also have hardware accelerated models, especially for computer vision, where you can use FPGAs. To conclude, it's an open platform. We support all open source frameworks, especially and including MLflow for Databricks and Onyx, which allows you to go between different frameworks, whether it's TensorFlow to PyTorch and vice versa, so that you don't get locked into a particular framework. And of course, we support some open data sets that we've made available in Azure. For a quick demo, I will show you Azure Databricks being used with Azure Machine Learning and SDK. So if you look at curbside pickup, you may get, let's say, an order online, which may have different products or items associated with different categories or aisles in a store. And your store may look something like this, but this can be rephrased as a graph analytics problem. And so there are many ways to search through this maze of store that we have, typically we find in our retailers. So for one order, it's okay, but now with pandemic, if you get 10,000 orders, how do you do that? It becomes a really complex graph analytics problem. And, I'll show you a quick demo for that. This is Azure Databricks. I'm using Azure Machine Learning SDK here and some network libraries. As you can see, I'm importing my Azure ML SDK, specifying my subscription and other information, which I've taken out for this demo. But you can specify that, and you can typically get started with your data frames. Start with some building the network, which is these different edges and nodes in the network. And let's say you get an order. The idea is that you're able to, for multiple orders, you're able to find an optimal algorithm to go from one place to another in the least possible time. So once that is done, as you can see in the SDK, once your model is trained, you register that typically like you would register with any other Azure machine learning model, and then write a scoring file, which allows you to do inference on the incoming data, and then provide the shortest path in order to fulfill your orders, and then deploy that. And that deployment script can then be specified here with different configurations and environments, and then basically it can be deployed from here to Azure Container Instances or Kubernetes service, which will produce a REST API. So this will be visible if I go to my machine learning workspace under Azure Machine Learning Service. So the SDK talks to the service, and it appears in the UI of the service. So the capabilities that I was mentioning, so notebooks, automated machine learning, designer, which is the drag and drop capability, these are all here. And as you register data sets, your data sets get registered over here. You have different experiments. And then as you go to different models, so the experiment that I just showed you, it would be registered over here. These models are then associated with endpoints. Those endpoints will show up over here. So like this is the retail graph service, which got deployed. In order to consume that, you can hit this REST endpoint. The keys required to authenticate are under this tab, which you can see now. I can then regenerate it later, but essentially this allows you to build really intelligent solutions rather quickly. So with that, I would like to say thank you and conclude my presentation for today, and stop sharing. So do you have any questions, thoughts that I may answer in the next few minutes, or?
Yeah, thank you. First off, thank you, Rahul, for the amazing and insightful talk. So we do have a couple questions. So I think we got a few minutes, so I guess we could go through it. The first question is about the example you just showed, the curbside pickup. Are you able to share that notebook? Is that notebook publicly available?
It's not publicly available. It's just a demo we had made, but I can go back and check if I can make that publicly available and then get back to you.
Okay, awesome. So the next question is specifically on the personalizer service. Is that available outside of Azure, or is it solely for a Microsoft AI setup?
So it's basically a REST-based API service. So you can you can call that REST API from anywhere, but it is obviously hosted on Microsoft Azure. But that shouldn't hinder you, right? You can still call that REST API from whatever software you're using.
And I guess is the CTC graph analytics demo also available?
So as I mentioned, like I can go back and check. What I showed was just a demo, and I'll go back and check. I'll see if I can make that available online and get back to you.
Okay, perfect. Seems like there's a lot of interest in the demos. Our next question is, what is the Microsoft version of Google Colab?
Okay. It's hard to compare a Ferrari with a Honda, right? But what I would say is that we have Azure Machine Learning Service, and in addition to the capabilities that some of our competitors provide, we have much more extensive capabilities here. Not only just notebooks, but we have automated machine learning. We've got designer capability, drag and drop capability. The fact that you can also manage all your experiments at large scale, create pipelines, manage your models with MLOps and endpoints capability. In fact, pointed to different types of compute and even use your own compute for that instance, and link it to different data stores uh, and data labeling capabilities. So if you see data labeling is especially useful for computer vision based workloads. So the point is we have much more comprehensive solution if you compare Azure machine learning with other competitors.
Definitely sounds like a much more comprehensive solution. So I guess the next question is, so you mentioned curbside pickup. Do you mind speaking a little bit more on what sort of trends in terms of use of Azure ML services that you've noticed that has helped retail meet their needs, especially during the pandemic between 2020 and so far in 2021?
So I think that is a broad question. I mean, in terms of trends, what specifically would you be interested in knowing?
So I guess more so about what is there any changes in adoption of Azure ML in that sense? Yeah.
Yeah, I mean, in general, we've seen a lot more demand, right? So curbside pickup is something that really did not exist before the pandemic, right? Like, that was not a way retailers would serve customers. And now every major retailer seems to be doing that. And so they were really not prepared for this type of demand. And once they got this demand, really, it was all about manpower, which is good because in a way it actually ended up creating more jobs. I've heard retailers hiring 10,000 people just for fulfillment of their products and services. But at the same time, in order to make it more efficient, graph analytics is one of the capabilities that can be explored. And of course, with Azure and Azure Databricks and Azure Machine Learning, you can use it for not only for machine learning, deep learning, reinforcement learning, SQL, but also graph analytic workflows. And that's what I wanted to show you today, that all these services can work together.
I see. Definitely the fact that it is such a comprehensive service really helps with the meeting new needs, right? So I think that's about it for the questions. Thank you again, Rahul. Kind of sad that I couldn't see you through the webcam, but hopefully we could stay in touch. And thank you everyone in the audience for joining us for today's talk.
Thank you very much for inviting me. Really appreciate it. And yeah, we'll get back to you on the other information.
Awesome. Thank you.
Thanks.